The strategic landscape of April 2026 is defined by a haunting realization: the magazine abyss. Operation Epic Fury exposed the lethal fragility of a missile-dependent fleet. Within the first 16 days, coalition forces expended over 11,000 precision munitions, depleting years of industrial production in a mere fortnight. This catastrophic consumption rate against low-cost drone swarms and massed salvos has rendered the current VLS-centric doctrine obsolete. The resurgence of the capital ship is not a nostalgic return to the past, but a structural necessity to house the massive power plants required for directed energy weapons, DEW. To avoid logistical decapitation, the Navy is shifting toward the Trump-class guided missile battleship, BBG-X, a platform designed to replace depletable missile magazines with the near-infinite ammunition of the Electron. The Trump class is built around a revolutionary integrated power system, IPS, capable of generating megawatt-class output far exceeding any current destroyer. This big laser main battery requires a massive energy reservoir to maintain beam coherence and sustained fire. Unlike the Arleigh-Burke hulls, which lack the growth margin for such energy-intensive systems, the BBG-X hull is a floating power plant. This electrical throughput is the heartbeat of the modern battleship, enabling the simultaneous operation of offensive main lasers and a secondary suite of small lasers for point defense. The shift from kinetic energy to directed energy is a fundamental pivot in the physics of power, ensuring the ship remains a threat as long as its reactors are online. A critical and often overlooked feature of the Trump class is the return of physical armor, a complete reversal of the unarmored destroyer era. For the first time in nearly a century, we see the implementation of a modern Citadel concept, utilizing advanced composite alloys and electromagnetic reactive layers to protect the ship's core reactors and command centers. This armor is not intended to deflect shells, but to survive the thermal stress of enemy laser strikes and the kinetic impact of hypersonic fragments. In an era where hard-kill active intercepts can be overwhelmed, the physical resilience of the hull becomes the final line of defense. The BBG-X is designed to take a hit and keep fighting, reclaiming the battleship's legacy of tactical endurance. Recognizing the shifting paradigm, China has abandoned its previous experimental designs in favor of a direct mirror to the Trump class. Driven by the need for shock and awe, the Chinese military is constructing its own class of massive battleships to close the technological gap. These vessels are being built with the same philosophy of immense displacement and high energy throughput, ensuring that they can match the offensive and defensive output of the Western counterparts. By replicating the battleship-scale architecture, China intends to project an equivalent level of naval dominance, creating a symmetrical threat that forces the West to acknowledge their status as a true peer power in directed energy warfare. The secondary armament of these modern giants consists of a sophisticated network of small lasers and electromagnetic railguns. These systems are designed to handle the low-end saturation threats, drones, small boats, and subsonic cruise missiles that previously forced the fleet to waste million-dollar interceptors. By delegating these tasks to the secondary laser batteries, the main big laser can remain focused on high-valued targets and long-range interdiction. This multi-layered approach creates an impenetrable bubble of directed energy, dramatically reducing the cost-per-kill ratio and ensuring that the capital ship cannot be swarmed out of existence. The return of the battleship is a high-stakes gamble on industrial endurance and design discipline. The technical audit of April 2026 suggests that while the Trump class and its Chinese counterparts offer a solution to the magazine abyss, they demand a level of industrial throughput that is currently operating at only 50% capacity. Success depends on moving away from gold-plated, unbuildable designs toward a sustainable production of large, survivable hulls. If the industrial base can meet the challenge, these directed energy platforms will define the next century of naval warfare. If they fail, these giants will simply be the most expensive targets ever floated, capable of winning the first exchange, but losing the long-term war of attrition.